So all of those decisions could be augmented by AI, and that's exactly what we're doing. So for the training data, we're getting all these cases of individual trauma. It could be like a blunt force injury, or it could be a fall. The falls are very common and very detrimental to certain populations. There's also things like gunshots, and we have to figure out how to triage each one of them.
Ahoj, počúvaš podcast Rozhovory MD, moje meno je Tomáš Havran a v dnešnej epizóde tu mám dvoch hostí a jednou je hostka, ktorá prišla až z Ameriky, bola tu na Slovensku, aby sa viac naučila o tom, čo sa deje v rámci AI na Slovensku, priniesla nejaké know-how z Ameriky a tou hostkou je Amina Ann Qutub, ktorá pracuje v Texase a takisto môjim ďalším hosťom a čiastočne aj komoderátorom bol Lukáš Vincze, angiológ z NUSCHu, ktorý teda bol aj v našom prvom ročníku inkubátoru. No o čom sme sa rozprávali? Rozprávali sme sa samozrejme o tom, ako vieme využiť AI v medicíne, aké má Amina skúsenosti v Amerike, na čom pracuje, a kam sa ten svet v AI v medicíne hýbe a ako ho môžeme používať, čo sú nejaké zručnosti, ktoré si máme budovať na to, aby sme naozaj ako lekári s touto technológiou vedeli pracovať čo najlepšie, tak aby z toho čo najviac benefitoval pacient. Tento rozhovor je v angličtine, verím, že vás to neodradí, bol veľmi príjemný, tak ako samotná hostka a tuto už je ten rozhovor, nech sa páči. Generálnym partnerom podcastu Rozhovory MD je farmaceutická spoločnosť Krka Slovensko s motom Žiť zdravý život. Welcome. Amina, welcome in our podcast, and also I'm welcoming Lukáš. Thank you for joining us, and let's talk AI.
Thank you for welcoming me. It's nice to be here.
Thank you so much.
Usually you're not here in Slovakia, but hey, look, we're talking here in studio in Bratislava. So what's your what are you up to here? How your days here in Slovakia look like?
I'm here as part of the U.S. Speakers Program, and so I've been able to get tours over the course of last 5-6 days at universities and hospitals that are at the leading edge of research in Slovakia. It's been really exciting.
Yeah, happy to have you. And you've been in 3 hospitals, you said, in
Yes.
Academy of Sciences. And was there something different, something odd, something that surprised you maybe, positively, negatively, however?
It's empowering to see some of the researchers who are focused on how they can make an impact very quickly in their communities and the endorsement of AI. So there wasn't, I think, this fear that maybe I was expecting to see of AI. And so it was interesting to see AI being used medically in radiology and even in surveillance, perhaps in some cities. And then on the other hand, this openness to be able to engage and learn about new areas of AI. I saw that throughout all the visits.
All right. Was there something that you learned, although you're quite deep in the topic, or maybe some new perspective that you gained?
Yes, there was a team in Innovia that's working on a vaccine for Alzheimer's disease. That was a brand new area across the world that was interesting. And they're trying to think of how they use AI to track human health as that individual is undergoing a therapy. So that's a new way of thinking about, how do you use AI in the medical field. Other things were today we got to get a tour of a research group that's focused on measuring human behavior and physical activity and performance.
In Jiva.
Yeah, cognitive performance.
Yes.
Yeah. That was really interesting as well.
Mm-hmm. All right. How many days in total are you staying here?
Just a week. So
A week.
Yeah, 7 days.
It's not it's nice that you stay in Slovakia for 7 days. It's I think considering many tourists coming here, 7 days would be already too many. But you as a professional coming here for 7 days, it's very nice, definitely.
Well, each day has been really packed. There's been at least 5, I think, events each day where I've gotten to meet new people in Slovakia.
Yeah. So yesterday you visited the Medifutura event.
Yes.
Where you had a presentation. Unfortunately, we both been there, but unfortunately we didn't catch your presentation. So maybe we could sort of kick off this topic with your presentation. Like what have you considered for this presentation? There were a lot of medical students.
Yes,
so
there were.
I suppose you adjusted the content of your presentation to them. What was the topic? How did you choose it? What were the main points? Let's try to summarize it somehow.
Yes. I brought with me to Slovakia a group of slide decks, I would describe it as, because I was informed going in that there would be different interests in my research and different parts of my research. So for this group at Medifutura, they were very much interested in the applied medical applications of research. So I brought with me a presentation that shared our work on working with 7 hospitals in the state of Texas to be able to implement an AI assistant, decision support tool for trauma care. And we're using a combination of large language models and other predictive algorithms to be able to optimize trauma care. So the medical students were really interested in that, in the details and the testing of that. And then also, how do we overcome some maybe fear also of using the AI assistants in the medical field?
Did you? Yeah, sorry.
Sorry. And this trauma care system, which is supporting by your AI, is like in real time works, or just going through all their cases and making the patient is preparing doctors to be better, or is just helping in real time in hospital?
Yeah, excellent question. Both. So we're training from 400,000 individual trauma cases from trauma cases since 2019 in the state of Texas. But we're also getting real-time information from individuals, and we're asking doctors like yourself to score the models. And we're not telling them whether it's a doctor or the AI that's responding to a case. And we're getting their feedback in real time as the AI or their fed information from another doctor. So that gives us maybe an objective way of being able to score our AI assistant compared to another doctor.
Could you maybe introduce this even further for me? Because I still feel like I can't really imagine the patient pathway with this tool. So how does it work in practice, or how can someone visualize this tool?
Yes. So trauma is one of the leading causes of death for young people in Texas. And so that's why it's such an important problem to solve. But in trauma, you can't predict who's going to have a trauma next, or to some extent, you can't predict that. At the point of trauma, in the U.S., there's a 911 call or a 112 call here. And once you have that call, there's somebody who makes a decision on who picks up that individual, whether they're taken by ambulance or whether they're taken by, in the U.S., helicopter, and which hospital they go to. That's the second decision, which hospital they're going to. And then there's another decision about what they're getting treated on or by, what tests they're undergoing, both in the hospital ride and when they're at the hospital. And then also, who's going to see them when they get to the hospital? What specialist is going to see them? So all of those decisions could be augmented by AI, and that's exactly what we're doing. So for the training data, we're getting all these cases of individual trauma. It could be like a blunt force injury, or it could be a fall. The falls are very common and very detrimental to certain populations. There's also things like gunshots, and we have to figure out how to triage each one of them. So there's a diagnostic part of it, and there's also a decision part of it. And each of those are made in the U.S. by different people who are trained in trauma. And so we're asking the AI to provide a response. Where should you transfer this patient? Should it be a level 1 center? In the U.S., a level 1 center is the elite of elite hospitals. It has everything you need. If it's a stroke, it would have an ability to immediately do a CT or perhaps MRI scan. It would have the stroke doctors. Whereas there's a lot of rural areas in Texas, too, that don't have level 1 trauma centers. So they don't have all the resources. They may not even have a trauma care physician on call. So in those cases, you have to make a decision. Should you go to a closer, less equipped hospital, or should you really make the decision this person needs to go to a higher level of care? So that we're getting the AI to make that decision.
All right. So it's a tool that the recipient of the call on 911, the operator is using to help them navigate the patient further, or?
Well, actually, yeah, it's a good question. So the 911 operator wouldn't be the end user of this. It's a clinician largely who's making a decision on transfers. We can, some of the support we're doing can be built for EMT, people who are responding in the ambulance. But largely the 911 call is the first to dispatch, but they're not making the decision on transfers. At least in the U.S., but yeah.
It's hard to grasp the whole process, obviously, so sorry for maybe such a detailed questions. So do I understand it correctly when I say that the tool is used by the doctor to help them make the decision, to provide some further information with maybe some like medical records and the previous data, and the tool was trained on to make a slightly better decision, maybe not just intuitively, but based on some data from the AI tool. So this is basically what we're talking about, right?
Yes, but we're hoping it's like transformatively better decisions, because there's a lot of cases where there were unexpected deaths and unexpected survivals. So we're wondering what's happening. That means somebody who came in with a severe injury and they survived for whatever reason, or vice versa. They came in with a small injury and they died. So can AI figure out how to optimize the care and the treatment for individuals like those?
Okay, I don't know. I have many questions.
Me too, but we was talking also that you are doing something like model of human brain with AI. Can you tell us more about this? Because I'm really interested in that.
Yes, that's a separate project, but it's one of my favorite. It's really interesting. So in the lab, we actually grow brain parts, and they're derived from humans.
As you do.
As everyone does,
we
right?
Grow brain parts.
I do get teased about that quite a bit at cocktail parties.
It's brain surgery,
yes. But these are derived from human blood samples or human skin in some cases. And then you can retain genetic information about individuals. We're really interested in growing part of the brain that responds to sensory stimulation in the environment or stresses in the environment. So the suprachiasmatic nucleus. And we're one of the first in the world to go after this and to build it. And the reason why we wanted to do it so badly is because it's one of the areas of the brain that's first affected in a lot of neurological conditions. So if you think about our wake-sleep cycle, this is the region of the brain that controls it. It controls circadian rhythm. It controls emotional response. It controls temperature regulation, and all in response to the light and dark, the sunlight we see or exercise we do. And so we're really interested in how does this small area of the brain, it's only about 40,000 cells, but it's so critical. It's such a master clock of the whole brain and of the whole body. So we're building this in a dish, and we're using AI to inform how we build it in part. And we're also using AI to analyze the cells and the structure of the cells and their activity and their function. And then on top of it, we're gathering data from individuals who, some of these individuals we've derived these the stem cell-based models for. Mm-hmm. And for a vast majority of the individuals, we've been tracking their circadian rhythm by wearable devices. And we've been trying to collect information about how they're responding to their environments and changing their circadian rhythm as a function of their environments.
Yeah, so you can answer my question if you tell my skin, because I don't like to wake up in the morning.
You're a night owl.
Yeah, I am night owl. I can be awake until 3 a.m. But when I wake up before the 7 a.m., I'm just dead. So probably you can also help to answer this question, if it's true or not. Because for me, to wake up in the morning is just the worst scenario ever.
And there is a lot of research, or not a lot, there is research sharing that genetic components are critical for when you wake up. So you inherit part of your propensity to be a night owl or to be a morning lark. What we're studying allows us to see a little bit of that. And what we describe is each individual has their own sleep stage signature. So we actually mine signatures of sleep. If you I think you're wearing a smartwatch, or maybe
I'm wearing Garmin.
Yeah. So you can track your 4 sleep stages: deep sleep, wake, REM sleep, and light sleep. And we make the analogy to base pairs of DNA. You have 4 base pairs of DNA. Mm-hmm. So we actually are using some analogous algorithms that are used to look at the sequence of DNA to mine people's sleep records, to look for patterns and motifs in sleep. So that's not merely how much you went into one sleep stage, but it's your pattern over many years and months. Mm-hmm. And that's what we think is so illuminating. And each one of us has, just like you were describing, each one of us has our own individual pattern of that activity.
I love this conversation. I think it was a very beautiful prerequisite to my question, because at the moment, AI is such a buzzword, and everybody sort of understands something else behind it, because somebody's radiologist and it means like, oh, it's going to help me read these images. Somebody's using open evidence, so it gives me good studies to derive some information from. And somebody is sort of just trying to understand some patterns, as you do here. So how do you explain people what is AI, maybe in this sort of like a whole family basically of different types of AIs? Like, do you know what I'm asking, sort of, and how you're explaining AI to people? What does it mean? If you should even explain it to medical doctors who are not technicians.
Yeah, that's a really hard question because in itself, you're right. There's so many facets of AI. When I've been introduced to the question of how do you address what AI is, I often try to make an analogy to the Turing test or start to describe the Turing test. Can you think of a computer being able to answer things the way a human would? And for our trauma care project, that works really well because we're trying to mimic the decision and thought process of doctors in that case. But for the computer vision one, where we're working with trying to analyze the parts of the brain, that analogy doesn't really hold as well because the AI is doing something that's beyond the human capability. So I just step back and say you're automating or you're interpreting things using a computer that in some ways was provided by Insight manually before. But that's a long-winded way of responding. So I would maybe ask you the same question. How do you answer that question yourselves when somebody asks you, what is AI?
Yeah, well, I had to explain this this Tuesday because I was running this webinar and I was thinking like, how would you tackle it? And yeah, like there are these different terms that for engineers, they mean something, but to doctors, it doesn't mean much. So artificial intelligence, deep learning, machine learning, generative AI, and for doctors, it's still just AI. Right?
Yeah.
And like, how do you explain AI when it's something that helps you just recognize patterns and like this above human specific, not even specific, because it can maybe read some patterns that are very general. For example, we have this company, maybe you met them, Powerful Medical.
Yes, we did.
Who are working with ECG, and basically their AI is looking at the ECG through angles that humans are not looking, right? So it kind of sees some different patterns. And at the same time, you have, for example, open evidence as a generative or large language model, which is trained on some medical data, articles, guidelines, and so on. And it provides totally different output for the doctor. So yeah, I was just trying to explain this cascade where basically there are different levels of AI, and some are maybe more kind of easy to use at the moment with the rise of ChatGPT and these large language models that everybody has their hands on. But then there are some deep learning algorithms that are trying to recognize some patterns in the images or in some other data sets that humans are not able to do, or it's very taxing to do it sort of manually with some non-AI algorithms. So I don't know, this was not a good explanation. But yeah, like I see that there are different basically things that can be hidden behind this buzzword AI.
Yeah, it's a lot of things, and also me and Tomáš, we are trying to convince doctors they should not be afraid of that, because it's not enemy, it's ally in our fight with the diseases and this stuff. And also I am going to all of congresses and trying to speak about how to use it in the easiest way for the doctors. And I see that if you say them, okay, are you doing these things more than 10 times a week? Yeah, so let AI do it, because it's like that. So for now I'm telling, okay, it can help you. For example, open evidence is one of the AI tool, which is really easy to convince the doctors to use, because it's, for example, for free. And actually, this name and Yama publishers, they're well known, and I think and it speaks Slovak.
Okay.
So, and
Simply put,
it's very easy for them to use, and they're using it after my any speech I will give. Like 50% of doctors will start to use open evidence.
Yeah.
It's fine, and and for me it's just starts, yeah. But in the moment, if you tell them, okay, but you can also, I know, you can just scan the messages, make them anonymized, and then you can use it to write all the things you write by yourself, and it will do it by itself. No, I don't believe that. Yeah, and it still is the same, because it's a generative language, and yeah, but for example, it's funny because in radiology we are using AI maybe 10 years.
Yes,
And nobody just know it, because we have this special software. If you have the stroke, the brain stroke, so it sees the ischemia more accurately than any physician. And actually, in all the hospitals in Slovakia, we already use it. And I like when I go into some congresses and like, oh, the AI is not good. But come on, you are already using that, but nobody calls it AI. They just call it different. So for me, AI is a lot of things, but all the things will help you to be better physician. And I think to start to learn about AI, maybe in the basic things like how to cook perfect ratatouille, it works very well actually. So start with that, and maybe then you can ask something which is from your field, yeah. But I want to, for example, for me, I didn't want to do any research in my life, yeah. But with coming of AI, I'm looking more that maybe it's not so bad to do some research, because all of this stuff, like, you know, the reading this all these reports and etc., is just time consuming. And do you think that AI will maybe bring more people to research?
I hope so. That's interesting. I was thinking that it would turn off people from research in part, because in at least what I've seen for academics, a lot of them leave for very lucrative positions in AI. So we have competitions in industry because of AI. But there's so much ingrained and so much knowledge that the cutting edge is still in universities and still in the research for AI and fields. Yeah, I hope that indeed AI leads to more fundamental research in AI and in medicine.
Yeah, because there are a lot of things, people who have good ideas, but they don't have like the time, and also they don't know how to do it. But for example, for me, it's all big help, because I say, okay, and I use also your GPT model, which you have.
OpenAI's, yes.
Which you put there, and I ask him how to make a predictive model for screening of AAA, and it gives me some insight, so maybe I will try. And thank you for that.
Well, definitely, at least it's helping, let's say, with the literature review. It helps with understanding some papers, some maybe things that you would not know, but you would just not have time, or you don't have the resources to have the assistants to go through all the literature and so on. So basically in this, at least you could be more productive, or even enter maybe research as a doctor. Yeah.
That's how you see it, that it's saving you some time potentially.
A lot. Like I'm super productive there.
All right. So this is something that I'm quite curious, how you see large language models in medicine, because you also mentioned in this trauma tool that you're using some large language models. I don't know in exactly what way. But there's this component of unpredictability, and there are some maybe legislative problems or in terms of making these tools compliant with some medical device regulations and so on. I don't know. I'm not an expert in this, but I would love to see your perspective and maybe how LLMs are used in medicine also in US, because what's used in US now, maybe in 5, hopefully, years is going to be also here in Eastern Europe. So what's your view at the moment on the LLMs?
Yeah, it's definitely still a new area of research for anything that's commercialized.
Mm-hmm.
And in the US, I think you mentioned radiology is a field where AI has been predominantly. That's definitely the case. In the US, there's over 1,000 FDA-approved AI applications, largely for radiology. So LLMs are this new beast in a sense, and FDA doesn't have a specific way of regulating it.
Mm-hmm.
So the regulation comes early on, pressured by the doctors themselves and by the universities and hospitals that are building them. And so, as an example, you asked about trustworthiness of these large language models for medical applications. There's a lot of steps that we go through to make sure that you don't have the hallucinations that have become so scary in the popular press. So we go from the very beginning and we look at things like the embedding of the language or the syntax of the AI that for whatever baseline models we use. And we're building our own medical specific and specific emergency care specific embedding data sets so we can train and we can know that we are not outside the bounds of what the AI has been trained on. The other thing we're doing is we're restricting the use of our large language models to specific domains in emergency medicine. And we have many other large language models that are constraining and judging our system of agents that decide on these medical cases. Other thing we're doing is that we're using our consortium of clinical colleagues, our expert radiology, not radiology in this case, but expert trauma care, expert nurses who are part of the trauma care team, to score each one of the large language models so we can compare them and we can compare the way we've modeled and integrated the new data on these data sets. We're also comparing it to real-time data that we're getting in from the 7 hospitals that we're working with. Mm-hmm. So there's a lot of checks on the large language models. So they are not unrestricted the way the ones you access now on the web are.
But officially, some of the tools are used in the hospitals, in a clinical setting, or
for care right now?
For care.
Sorry, go ahead.
Yeah, because you said that commercially not yet, and mm-hmm. This means that it's just like for research purposes at the moment.
Testing, yes.
Yeah, testing, sort of. Mm-hmm.
Yeah.
All right.
So we're doing right now what we call preclinical trial testing. Mm-hmm. So we're asking the teams of doctors around Texas and around the nation to be able to score our models on real cases. And they're blinded, whether it's one of our algorithms, whether it's a ChatGPT, whether it's Grok, or whether it's another doctor. And so they're scoring results to cases. We also are scoring against actual cases of trauma care and what was performed. And then we have to do clinical trials. So in the U.S., that means you have to show that you're just as good as the state of care and largely better. So you have to say that if a doctor is using the AI assistant, you're going to have a faster time to care for trauma, or you're going to have better outcomes, less fatalities. Mm-hmm. And that has to be proven before it's going to be actually able to be commercialized.
All right. How many years, months until we see commercial applications of some tools using LLMs? Or
I think it's coming within a year or 2 years. Mm-hmm. We're innovating and we're building at a very fast pace. We're 16 months into the project that I'm describing. We built up this team of networks of 7 hospitals already working together, 30 clinicians on our team, and their teams have dozens of people behind them. We're sharing a data set that's across the whole state, across all the hospitals to train on. So the development is very fast. Mm-hmm. And there's an analogous project that's started up in London too. So they're trying to build LLMs for the City of London for trauma care. And again, their time frame is around the same time. They want to be in clinical trials by 2027.
All right. Interesting. Quite, it is one of the things that I would not consider being on the frontier, maybe, like the trauma. Because always when I think about this sort of like doctor-facing AI with LLMs, it's I see always some internal medicine doctor, angiologist maybe. But usually for surgeons, is quite, let's say, far. But like this prior surgery, this kind of decision making and navigating the patient through the system, it's can be quite helpful also here, yeah.
Yeah, but I can see that, for example, for me, maybe the stroke protocol or the time is brain. I know that in US you have the special ambulances which already have CT inside the ambulance. So if you are in a stroke, brain stroke, so if the operator can say, okay, you send this ambulance there, so they can make stroke protocol CT in the ambulance. So probably when these big models will know from the basic anamnesis to say, okay, this patient has really high risk of stroke, which needs to be thrombolized or something like that. So maybe in this you will just get a really much faster response for that. And also probably maybe this is also like the trauma, because in this trauma, how you said, sometimes it's small injury, blunt injury, and you say, okay, it can go to some tertiary hospital, and that but this blunt injury can be rupture of spleen, for example, and it makes sense if you think, probably they think about that before. Yeah, but what we said is true, that you will imagine more these LLM models in ambulance, high, big differential diagnosis and what it can be for patient.
Yeah, it definitely helps with in the workflows for basically the patient's journey in the healthcare system.
But what I like from your conversation, you said that you are working with physicians.
Yes.
And I think, what is your opinion for me that it should be cooperation between technicians, because you are the scientist and I think you all have some chemistry degree. True?
My original degree was in chemical engineering.
And
biology.
You went from that, but still physicians should be helpful with these AI models. It's true.
They're partnered in development with us on it. Absolutely. They're critical. But I can't credit myself with making that partnership. When I first applied to get funded on this project, I applied just with my AI team. And then my clinical colleague in emergency care, he applied with no AI, asking to build a new repository of data across the state of Texas to get better quality data and to have a universal shared data set. And the funding agency, which is the state of Texas, decided to partner us together. And they gave us more funding than we expected, with the requirement that we work as a team. And that was really foresightful, and because it enabled us to build in parallel a decision support tool that worked for the doctors and really was informed by what they need.
Yes, so quite inspirational policy making or sort of organization of the teams from the state of Texas, right? I'm curious if you have some insight into how doctors are using AI in the US. And I know it's quite a broad question, but maybe we could also focus more on this sort of doctor-facing AI, not the one that is hidden somewhere and is recognizing some patterns. Do you have some insight here?
Well, they are using open evidence. That's true. They also are using...
For educational purposes only, right? Or
just to know. But they also are using the other available open source, or not open source, commercial large language models, just to search up things for helping them on a diagnosis, as an example for an extreme case. Ingrained in the U.S. medicine also is that the hidden AI in a lot of image-based analyses. We have another project where we're working with a group of burn surgeons, and they want to have AI that looks at burn depth and overlays that on a burn.
Yeah.
So when you make a surgery, you know exactly where you're incising the tissue and you're not making an error in that. It's being used in automation. So for robots in the operating room, as an example, AI is an integrated part of that. So in all of those areas, it's being applied. There's other applications that if you think about like space medicine, some of the decision support that we're building is critical in part because you don't have the doctors present. You have an astronaut being their own doctor. So in that case, you need decision support, which is just as good as the doctors themselves, if not better in that case, but you don't have the doctor to make the actual medical care. So those are some of the examples of where it's being used.
Great. Was there something in the past year maybe that some advancement, some development, some new paper, some new tool that really surprised you in a positive way? And it's like, okay, now the whole field is, one step further. Although a lot of times we see these kind of miracle advancements, but was there something that surprised you as a person from the field? Like, wow, okay, we made a huge leap forward. Was there something in the past year that you thought these kind of thoughts?
It's not a single thing, but it's this initiative by the commercial companies and research labs to put out their gold standard data sets to test the models, the large language models specifically. So like Health Bench from OpenAI was put out there, and this is a data set of medical questions and cases where there's over 250 doctors around the world that vetted it. And then there's these other open source evaluations of large language models that are out there and that have been published on GitHub or put out there on GitHub. And internally, we're also developing a data set which will be made open to everyone where they can vet large language models for emergency and trauma care. I think those are important initiators for large-scale innovation because it allows people to standardize and compare across models. The other thing I would say, there's also innovation in AI for bio that's taking sequence data, so DNA sequences and protein sequences and molecular sequences in general, and training large language models off of that type of sequencing data rather than text. And there's been a number of advances in that field. So you can think of designing a new therapy using these large language models, but it's not language that they're training off of the traditional language.
It's actually quite interesting that you can basically not just predict another word, but another disease, another sequence of amino acids. So that's quite interesting.
Yeah. And I just listening and it's very interesting. So do you think in the future it will be that if you will get the sequences of DNA from some person and you can make like Tomáš 1 and Tomáš 2, and on this Tomáš 2 you can be like predict like make him older and predict what diseases he will have in future, what pharmacies will work for him, which not. And do you think this is the future of preventive medicine?
Yeah, absolutely. You mean digital twins, really?
Yeah.
That's the area. Yeah, so one of my startups that I have is focused on identifying digital twins in some ways on behavioral data for individuals. So yes, I think that's a growing area. Absolutely. Yeah, It's interesting.
Now, I remember we had these, because at times I'm trying to educate doctors on what is AI, how to use it, how to just sort of mostly like build this AI mindset that, there could be some problems that AI might help you with, and you should identify them possibly. And then there's obviously, let's say, ChatGPT or other large language models that you can use to further help you with some administrative tasks and so on. And with some critical thinking, it can also help you in maybe some differential diagnostics, but with all the limitations it has. However, without any training, patients are already using ChatGPT to improve their health, to diagnose themselves. And I, from very like basic point of view, I think it's awesome. I think it's definitely way better than just Googling something and seeing some SEO amplified answers or articles. But doctors, like some doctors, are quite furious or maybe scared that patients are using this because it can either harm them or the patients are going to come with some pre-read data inputs, diagnosis the doctors are not aware of or have some, I don't know, can't have the discussion basically. So what's your take on this? Should patients use ChatGPT or it's not advised for healthcare applications? What's the maybe also take in US? So how is it seen basically?
It's being used for sure by individuals to look at their medical care. And there's definitely been cases where somebody with a rare disease found out information from one of the chatbots and they found it really useful. You already described like the trade-offs that yes, in some cases there might be harm caused by it and it might annoy some doctors. But on the other hand, it's just another resource to bring to the table. And when you go into the clinic, if a patient has that extra information and provides it to a doctor, I think it's on the doctor's onus. And you may actually correct me, but I think it's on the doctor's onus to be able to, at their fingertips, have something like open evidence or another tool where they can quickly check what that patient came with and see themselves whether they would find out new information using these available large language models, because they're able to learn from so many more resources than the doctor themselves have trained off of. And even if you think of a single doctor, these large language models are training off of potentially tens of thousands of doctors. For our emergency case, we're training off of many doctors, many experts in the field. So you have that benefit that a single doctor wouldn't. And doctors themselves, they ask for second opinions, right? Third opinions.
All of them, yeah.
I think it kind of strengthens the argument to really build this AI mindset and even the skill set. Mm-hmm. Because if the patient comes with some ChatGPT answers to their medical concerns and questions and stuff, then the doctor should know, like, okay, first, what it is, how does it work, how can I verify this or discard this, and suddenly you need to know how to operate at least ChatGPT, possibly some, more advanced medical diagnostic tools. But like, would you consider it safe? Like, would you recommend patients using this? It's a strong verbatim, of course.
Oh, not ChatGPT. So there are ones that are more focused on medical applications, and there's a lot of development in that.
Yeah, but towards patients, let's say, or like as a patient, what possibilities do I have to learn something about my diagnosis or get some medical advice? Again, strong verbatim, but besides ChatGPT, but that's very available. So that's why I'm saying specifically ChatGPT, but maybe you have some other tools that could be recommended for patients.
I think all of the big commercial large language model developers are building their own medical specific large language tools. And so like MedPom is an example. There's GemMed or Gemini's version from Google. OpenAI has that a large development in that area too. So those are coming. So maybe one would argue that those would be a first pass of tools that people start to use. But I actually think the power of AI comes in a little different ways. And you brought it up very early on when we were talking about PID. It's not a one-off. It's not like one instant in time of that individual, and that individual puts their information on a chatbot that day, and you really learn from a lot from it in that instance. I would argue it's the longitudinal tracking of an individual's health where AI can make the most difference by inferring patterns and changes relative to yourself. So I think the power of using AI for an individual for their health will be in collecting their own data and training their own confined model on their data to learn patterns of their own data and see so there's something changing so that they can preemptively know that there's a change in their health status.
So that could be very powerful.
So you will have your smartwatch, which will like monitoring you all day, all the time, and if there will be some abnormality, so probably if they've already, the temperature is going higher, something is happening. and also probably it will be record all your lifetime, because it's much easier now to make your, you just come to doctor and you just okay, all diseases which you had already before will be stored somewhere. From your work, I see that you are visionary, because you are not staying in one field, but you are going in your work in a lot of fields. What is like your vision in 5 years? Where will be not only AI, but like all medical researches, which will be the main field, in which we will focus. It will be more, because I think we still are lacking the prevention. And I know also that the US is a big problem, the prevention of all cardiovascular diseases. So do you think that also AI by different tools will help us to manage these things? Because still it's much cheaper to manage healthcare before these diseases will come, because after they come, you just are treating. But do you think the future will be in prevention?
I definitely do think a part of the future will be in prevention. And it also relates to daily monitoring of your own activity and knowing that it's a daily process to prevent chronic diseases, as an example. So having an AI that is really encouraging you on a regular basis to upkeep your health, I think will be very helpful for innovation in AI. There's other things that AI right now doesn't bring to the table that doctors do. The other senses we have. We've had a number of discussions this week on some of newer work we're doing on the AI for trauma care and my neurological AI, is that you bring in the palpation, the tactile touch that a doctor has, the intuition from smell and sounds in the environment. All of those are not captured yet by most AI models, and they can be. And that starts to get at areas and gaps where AI medicine is missing. You really can't have the care, the tenderness of a doctor, because there's a lot of things that are lacking in these large language models, largely because of the types of senses and the type of data that it's able to train off of. So I think we're going to see in the coming years a shift in modalities and thinking of how AI can be used. So it's going to help more in both prevention and also in treatments. But it's because it's bringing in more human senses and more human abilities and then augmenting those.
It's quite interesting that we're trying to, as you're saying, augment some human capabilities with AI, which is not like sort of naturally built in a way that it would augment, say, touch or smell or whatever, rather than trying to figure out totally new ways how we can diagnose something without these human capabilities. I know it sounds very nice and tender and so on to sort of emulate the human touch, but maybe there's a completely new approach in this, I don't know, like some scanning or whatever. But it's quite interesting that as humans, we try to emulate this human way of diagnosing and so on. I'm not saying that we should do it one way or the other. Is just interesting to me to observe this.
It's coming both ways. I think it's that you're recording digitally things that a human doesn't detect, but at the same time, we're right now lacking a lot of the human abilities in the AI. So if we bring those back in and pair them with the automation, you get in some ways, in some areas, superhuman abilities in the AI. And I think there's fear in that, but there's also this great promise of that.
No, we actually talked yesterday about if you are very good in taking history and measuring some vital signs and so on, and maybe and just doing speech to text to some LLM, but very precisely talking about everything you heard and felt and so on, then the AI can actually do some diagnostics on that or prediction and so on. So at least at the moment, you can use AI without these capabilities just by you doing your work properly and let's say putting it into some chat box. end with this question, or this comment basically, I would get to my last question, which is what competencies or what skills should doctors learn, improve in this era of AI in medicine as well?
I think you touched on it too in your last comment. It's being open-minded, the ability to think outside the box and being willing to try new technologies. And I don't think that's a problem with a lot of the young residents. Probably you're seeing that yourselves because they're just learning. So everything is new to them. So if you're introducing something from AI, that's no different than introducing a new area of biology in that sense. But also to not neglect that there's a whole bunch of unknowns about the human body that AI is not going to be on its own able to discover. So that's why, I still want to always maintain my wet lab to understand more about the human physiology and about the human brain itself, because I think we'll learn a lot from that. And then, of course, there's the ability to explore other organisms and even other planets. We're going to learn a lot from the way communication and forms of communication take place across all modes of life. And that will inform new technologies beyond AI. So I think keeping an open mind is really the advice I would suggest. And I'm curious as to what you would suggest.
Yeah, I am open-minded. So when everybody around me just know that I think it will just help us to do things better. And I said it's like a step back to the medicine which was learned by our teachers, the good physical examination, very good anamnesis. And I think because we are lacking that in our practice, you can see that a lot of time you have some multidisciplinary approach, and you just ask, did anybody touch the patient? No. Yeah. And this is not because it's just happening because you don't have time and you are just focusing on the labs, on the CTs, on the MRIs, and etc. And for me, I think a lot of these things you can manage by your basics, yeah? And so probably for me, you will get more information from basic examination. And also we know that this extra examination, they are not really cost effective. So on the end, because and also what I like about AI that I'm talking is my mother, she's 60, not this year. And I show her the AI and she's using it like in daily practice. And I said, I have the small doctor house in my pocket. And if I need something, so I just ask him first. And she's working in small city, and she said, and I think I still have better opinion that to send it some different surgeon. And she and this is I think the best thing, that you have a lot of experiences. She does, but she said, I'm not able to read everything, because for example, in every field there is thousands and thousands research papers published every day, and you are not able to read that. So, but you have small gadget in your pocket who can do it for you, and if it make you sense that, okay, so this makes sense, so I will put some ibuprofen for some inflammation disease, and it will be fine. And it's like that. So for me, open-minded, try to use it. Don't be like, okay, it doesn't work once, I will not use it anymore, because you say, it was the same with MRIs and CTs and sonographies. Yeah, in the beginning, only person who used sonography was radiographer. Yeah, and now it's just basic on the trauma protocol. Yeah, in trauma you have sonography, the small iPhone or something like with small probe, and just go for these spaces. And we should be open-minded. And I'm glad that I know some persons who are helping to develop AI in medicine. Thank you very much.
Thank you.
All right. So open-mindedness, this is still human touch. Maybe even with more technology, we could become even more human because we don't have to look at the sort of computer tables, lab results, images and stuff. We're going to have it on our fingertips. And like for me, it's always this critical thinking when you're using all of these tools. Like you are the last decision maker, and you need to know what you can count on and whatnot. So yeah, thank you very much for the interview or the discussion. It was nice, lovely, and insightful.
Thank you. It was great to be on your podcast.
Thank you very much. I enjoyed that. Thank you.
Práve ste dopočúvali našu diskusiu o AI v medicíne. Verím, že sa vám páčila a budem veľmi rád, ak ju posuniete niekomu ďalej.